Integrated Math 1. Welcome to Module 2, Topic 1, Lesson 5. We're doing the first half of it today with the first couple of activities. And of course, you'll finish out this lesson, the next couple of activities next time. So we have been looking at all these different ways to represent our linear relationships. We can represent them with tables, with equations, with scenarios, with graphs, right? We have all these different ways of representing our linear relationships, and we've been playing with moving in between all of these guys. So here's what we're doing for activity 5.1. I would like you to consider the line that represents the equation 4x plus 3. Just looking at this equation, I know several things. I know it's a linear equation, right? There's no exponents, nothing weird happening here. It definitely fits that whole f of x equals ax plus b, so it's in general form, which means I know my slope is 4, my rate of change. I also know that my y-intercept is that number hanging off the end, and that's 3. So I actually know quite a bit about this function without really making any effort. I know several things about this function already. Now, here's the deal. For question number 1, you have 6 different guys going on there. You have you have A through F, you've got some tables, some equations, graphs, scenarios, you've got all kinds of stuff happening here. And here's what I would like you to do. Now that you know that the slope of this guy is 4, that's super important. You know your rate of change is 4, your slope is 4. I want you to look at every single one of these, A through F, and I want you to determine whether the graph of each linear relationship is parallel, meaning they have the same slope, perpendicular. So actually, I'm going to make a note of this. So parallel, we said, hang on, let me get my pen going. So parallel, we said, means that my slope is the same. So make a little note of that, same slope. Perpendicular means that our slopes are negative reciprocals, or you could say opposite reciprocal. Either way works for me. Opposite reciprocal, where we had to change the sign and flip it, right? Both things have to happen, or neither. Maybe it's not, the slopes don't match, and maybe the slopes are not opposite reciprocals, and so it just doesn't work, and it's not parallel or perpendicular. But what this means for you is that for every single one of these problems, A through F, the first thing you need to do is find that rate of change, find the slope, and then see what it looks like compared to our original slope of 4. For A through F, do it for every single one of them. So go ahead and hit pause, work your way through all of them, A through F, and then hit play when you're ready to check your work and see how you did. Now, of course, I suggested that you hit pause and do them all. If you just want to hit pause in between each one and do them one at a time, totally cool, totally understandable as well. So we said if I want to know parallel or perpendicular, I clearly need to look at the slopes. I didn't write slope there. I clearly need to look at my average rate of change. I clearly need to look at my slopes. That's super important. So the first thing I'm going to do is look at the slope. We said for slopes, I just need to know rise over run. For a table, that means I just need to pick 2 points. And I can use my slope formula. You remember your slope formula? How you have to do the whole subtract your y's on top, subtract your x's on the bottom, and that'll help you find your slope. So pick 2 points to make it easy. I'm just going to pick these 2 points. It sounds good. They're there. They are convenient. So I'm going to do 4 minus a negative 6 on top, and then 0 minus a negative 2.5 on the bottom. We know that the double negative up top and below does give us positives. So actually I have 4 plus 6 and then 0 plus 2.5. 4 plus 6 is of course 10 and 0 plus 2.5 is of course 2.5. If you have a calculator handy, could be useful. 10 divided by 2.5 is actually 4 on the nose. Now we know that this guy's slope is also 4. Check it out. The slopes match perfectly. They have the same slope, which tells us that our lines are parallel. Yeah, this table, this function is totally going to be parallel to this guy, to our original function of y equals 4x minus 3. Hooray! Let's go to B. So for B, I have a scenario where I'm told that an elevator descends 4 feet every second. So let's again look at that rate of change because that's going to tell us parallel, perpendicular, neither. So if it goes down 4 for every 1 second, so I put negative 4 over 1, and you don't need a calculator for this to know that negative 4 divided by 1 is a negative 4. Well, it's not the same as 4, a little bit off, so I know it's not parallel. It is the opposite of 4, and that's positive, that's negative, but in order to be perpendicular, remember, it has to be a negative reciprocal. It's not enough that we change the sign. We have to flip it, and of course, if this is 4 over 1, the reciprocal will be 1 over 4. So it's not the reciprocal. So it's not the same, and it's not a reciprocal. So not the same means it's not parallel. Not the reciprocal means it's not perpendicular. So it is neither parallel nor perpendicular to our original equation. That's how it goes. That's what happens. Part C, determine whether the graph of each linear relationship, okay, parallel or perpendicular. Oh, slopes. I need the slope. I need the average rate of change. Well, this one's a nice one because, again, it's in that general form, general linear form, so that's kind of nice. So sure enough, here is my slope right there, 1/4. Okay, it's not the same as 4, so I know it's not parallel. It is a reciprocal of 4, though, right? We said that this was 4. You could write this as 4 over 1. So it is a reciprocal. That's a good sign. Except to be perpendicular, it has to be the opposite and the reciprocal. And while it is a reciprocal, they're both positive. So it's not perpendicular either, is it? Well, that's lame. So it's neither parallel nor perpendicular. That should say nor perpendicular. Sorry for the typo. I'll fix it later. All right, part D. Now this one was a little trickier. In order to find the slope, there are lots of ways you could have done it. You could have counted rise over run. Basically, I started by picking 2 points. If I'm going to find the slope, I need to pick 2 points. And to make life easier for me, I picked the y-intercept and the x-intercept. I figured that would be easiest to do. My y-intercept is at 0, -1. My x-intercept, it looks like I went 4 right and up nothing, so 4, 0. So let's use that to find our slope, our average rate of change. Again, subtract your y's on top, so so I did 0 minus a -1 over 4 minus 0. Double negative, of course, becomes a positive. So 0 plus 1 is 4, and 4 minus 0 is 0 plus 1 is 1. Woo! Does it worry you when your math teacher can't count or add? So 0 plus 1 is 1. And of course, 4 minus 0 is 4. So we get 1/4. It's the same issue we had on the last problem. It's not the same as 4, so it's not parallel. And while it is the reciprocal, it's not the opposite. They're both positive. So it's not going to be perpendicular either. So it is neither parallel nor perpendicular again. Wow, that typo is just persisting, isn't it? That should say nor. That should be an R. Sorry. This is why I don't teach English, right? It's fine. We got 2 more here. So here I have another table. So let's treat it like the very first one, right? Where I pick 2 points and find the average rate of change. Because again, I got to find that slope. Again, to make my life easier, I'm just going to pick the first 2 points, subtract my y's, subtract my x's. So 2 minus 3 over 0 minus a -4. Of course, 2 minus 3 is a -1. Double negative here becomes a plus, a positive. So 0 plus 4 is 4, and that means I have a -1/4. All right. It's not the same as 4, so it's not parallel. But it is the reciprocal of 4, right? So 4 over 1 becomes 1 over 4. Oh, look, and he's positive and he's negative. They are negative reciprocals. They are opposites. This is great because this tells us that our line is perpendicular, that our table, if we were to graph this table and graph this line, they would be perpendicular to each other. Nice. Finally found a perpendicular one. I was getting a little discouraged there. One more. Order now and we'll throw in another problem absolutely free. So we've got one more problem here. We have a lovely scenario. For every hour Chilezzo bakes, she makes 4 dozen cookies. I think she and I need to be friends, especially if they're like chocolate chip cookies or snickerdoodles. I'm just saying, it's always good to make new friends, especially a friend that bakes. So for every hour Chilezzo bakes, she makes 4 dozen cookies. So again, I'm going to write that as a slope, as an average rate of change. So if she makes 4 dozen cookies every 12 hours. So 4 dozen per every 1 hour, just kidding. So 4 dozen cookies every 1 hour. It's 4 over 1, which of course 4 divided by 1 is 4. Look, it matches exactly. Ooh, so what does that tell us? If it's a perfect match, it's parallel. So if we were to graph this scenario and graph this lovely line, they would totally be parallel to each other. So magical. Hooray! So again, the idea is if your slopes are the same, they're parallel. If your slopes are negative reciprocals or opposite reciprocals, depending on who you talk to, how they phrase it, then they are perpendicular. Hooray! All right, now let's get down to the nitty gritty and where things get useful. I'm a good girl. I recycle my stuff. I recycle whenever I can. But there are large recycling centers that actually pay you money. And you guys might know some places in the area that you can go to and bring your recycling and they'll actually pay you for it, which is kind of nice. So I've got 2 recycling centers here. And large recycling centers pay out different amounts per ton of cardboard recycled. Washington County Recycling Center lists its payout amounts in a table. So they gave us this lovely table here. And Jackson County Recycling Center uses a graph to advertise and represent its payout amounts. So the 2 centers' payout amounts are close, but they're not quite equal. So we need to take a closer look at these guys and see where we can get the better deal. So we're going to do this a step at a time. Each representation, the table, the graph, they each show a functional relationship between our quantities. So what I'd like you to do is to label the quantities and their units in the table and on the graph. So put a label in this part. So what does this column represent? What does this column represent? And same thing here. What does your x-axis represent? What does your y-axis represent? It might be helpful if you take it back to Module 1, Unit 1, where we talked about independent and dependent quantities. It might be helpful to kind of take it all the way back there and remind yourself, what's my independent quantity? What's my dependent quantity? What are my units for those things? It'll help you label your stuff. So right now we're just labeling our table and labeling our graph. Go ahead and hit pause to do that and then hit play when you're ready to see how you did. All right, so I realized that my input, my independent quantity, is the amount of amount of cardboard I'm recycling, right? How many tons of cardboard I'm recycling, that is my independent amount because that's what I'm bringing to the table. That's my input. So I put that right here. I said, all right, weight of my cardboard in tons. How much cardboard am I bringing to recycle? That output is, of course, how much money they give me for it, right? How much are they paying me for the stuff I'm bringing in to recycle? That's my output. That's my dependent quantity. So, of course, I'm going to put that here. My payout amount, which is, of course, in dollars. Yay, we like that. Now, of course, you remember that your input is your x-axis and your output is your y-axis, or maybe you remember that the independent quantity is your x-axis, the dependent quantity is your y-axis. Either way, we should say that our x-axis is, again, the weight of cardboard in tons, and the y-axis is our payout amount in dollars. How much money am I gonna make? Yeah. This is important because it's going to help us answer the next several questions. So remember, now we're going to use function notation. Remember how this works. We're going to let Wx represent the function for Jackson County, and J of x represent the function, pardon me, I can say this right. W of x represents the function for Washington County, and we'll let J of x represent the function for Jackson County. And we're going to use a greater than, less than, or equal to complete each statement. You have several statements, A, B, and C on down here. You're going to complete all of these statements with either a less than, greater than, or equal to. Don't freak out over this notation. This just means if I give Washington County half a ton of cardboard, how much money do I get out of it? If I give Jackson County half a ton of cardboard, how much money am I going to get out of it? So I'm going to go ahead and have you hit pause, answer all of these questions, A, B, C on down there with less than, greater than, less than, or equal to. Go ahead and hit pause, see what you can do, and then hit play when you're ready to keep the discussion going. All right, so this is W of 0.5. So this means this is W, right? W of x. And if I plug in a 0.5, how much money do I get for it? Well, if I bring 0.5 tons of cardboard, I'm going to get $7.50 from it. But I also have J of 0.5. So if you recall, we said Jackson County was J of x. 0.5 tons of cardboard is here. And if I go up, and I make a little, oh, that's bad. I have to erase that. That's a mess. Don't do that. But I'm going to make a little dot right there. Boom, there's my pretty little dot. It is oh so pretty. How much money? So 0.5 tons of cardboard here gives me, so 0.5 tons of cardboard gives me $10. Hey. So less than, greater than, equal to, that's totally a less than. Washington County is going to give me less for my half a ton of cardboard than Jackson County is. How'd you do on this one? So treat this one the same way. Again, this is my W of x. This is my J of x. Great. So when I plug in a 1, what do I get out of it? Looks like I get $15. Over here, if I plug in a 1, and it smacks right there, it looks like I get $20 out of it. So greater than, less than, equal to, well, it's less than. Once again, $15 is less than $20, right? That's kind of how that's going to go. But wait, there's more. Now this one's tricky. Because it says W of 3, and yes, this is W of x, but there's no 3 down here. There's no 3. The other issue I notice is that it says J of 3. And again, while 3 is here, my line doesn't go that big. So I had to get a little creative on this. Maybe you extended your line, maybe you kept your table going, but here's what I noticed. I noticed that in Washington County, that they were giving me $15 per ton of cardboard. Did you catch that? Did you also catch, courtesy of that last problem here, that over here, when we did 1, that last problem we did 1, and we got $20 worth of cardboard from it? So that means that Jackson County is giving us $20 per ton of cardboard. So if I'm doing 3 tons of cardboard, well, okay, $15 per ton, but I'm doing 3 tons, fine. 15 times 3 equals 45. So it looks like Washington County will give me my $45. Jackson County, or J of x, well, if it's $20 per ton, but I have 3 tons, I can just do 20 times 3, which gives me 60. So it looks like Jackson County, when I plug in that 3, will give me $60 for my 3 tons of cardboard, which again, $45 is less than 60. I hope you're noticing a pattern here. So I would like us to compare these for just a moment. Compare the y-intercepts of each relationship. What does the y-intercept mean in terms of the relationship between my weight of cardboard and my payout amount in dollars? Go ahead and hit pause, jot down your thoughts on this, and then hit play when you're ready to check. So this one's pretty easy. I can see that the y-intercept is 0. And actually, if I were to subtract 1 and subtract 15, I'd end up with 0, 0 here as well. So it looks like for both of these functions, the y-intercept is 0. And this makes sense because what does this mean? This means that $0 is paid for 0 tons of cardboard. And that's fair. If you don't bring any cardboard to recycle, they're not going to pay you out for it. So, all right, fair enough, fair enough. Man, you must have a big truck to be carrying around all these tons of cardboard. I don't think my tiny little hatchback is going to do that. So, here's the final question. Which recycling center would you choose to use, Washington County or Jackson County? And provide evidence to justify that choice. Go ahead and hit pause, jot down your thoughts, and hit play when you're ready to check your work. All right. I hope you noticed something super important as we were doing this earlier. Did you catch something really, really important when we did this earlier? I hope you did. I hope you caught that Jackson County was paying out $20 per ton and that Washington County was paying out $15 per ton. We mentioned it earlier, but it's important to notice that now because you know what this means. This means I would choose Jackson County Recycling Center because their payout rate is more. Jackson County is willing to give me $20 per ton, and Washington County Recycling Center is only going to give me $15 per ton. Of course, I'm going to go to Jackson County. I can make a little more money that way. Also, what are you doing that you have this much cardboard? I mean, actually, I take that back. I order a lot off of Amazon. Maybe I could get something for this. I'm going to have to look into that. In the meantime, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, please feel free to email me or come see me during office hours, and I'll see you soon. Bye, guys.